Our fourth objective on practice test B. Given the hydrogen ion or hydroxide ion concentration, we're being asked to calculate the pH. We'll also need to know if the solution is acidic, basic, or neutral. This has us remember some relationships between the hydroxide and the hydrogen ion. We understand that pH can be found by taking the negative log of the concentration of the hydrogen ion. Negative log of H plus gives us the power of hydrogen. Also, the pOH can be found by taking the negative log of hydroxide ion, OH negative. Understanding the relationship between the two based on the ion product constant for water, we know that the sum of the pH and pOH always gives us 14, the top of our pH scale. If these need to be pH units, we have to make sure that we're measuring indeed the power of the hydrogen ion, the acid ion in solution. So as I glance through my objective 4, I notice that letter A gives me a hydrogen and letter D gives me a hydrogen, and that I'll be able to directly hit the negative log to find hydrogen. But I notice that letter B, letter C, and letter E give me the hydroxide ion concentration. And when I negative log those, they give me something called the pOH. So 14 minus that is going to turn that into the pH. So let's begin looking at hydrogen ion concentration in letter A. When we hit for our pH, it is as simple as hitting, and I can show my calculator keys, we will hit negative log, and it will appear on our screen, of 6.3 E negative 2. Negative 2. Negative log of 6.3 times 10 to the negative 2 will look like this on your screen. Hit equal. So I'm seeing 1.20 as my pH of the solution. Now, knowing that 7.00 is neutral, below 7 gives us acid, and greater than 7 gives us base. The value of 1.20 is well below the 7. This will be an acid in the pH range. So, letter B. Again, indirectly we have to calculate pH by hitting negative log of hydroxide ion first. Let's begin with the letter B by hitting negative log of 1.2 E negative 13. And my screen shows 12.92, but remember that's the pOH. 14 minus that answer turns it into a pH reading. And that value is 1.08 for our pH of our solution. And again, well below 7, that is an acid in the range. Letter C also gives us hydroxide. So when we hit for letter C, we hit negative log of 3.1 E negative 6. And we get something called the pOH as 5.51. 14 minus the pOH value turns it into a pH. And this is giving us a value of 8.49 on the pH scale. 8.49 is in the base range, again above 7, 7 being neutral. Letter D gives us hydrogen ion directly. No need to 14 minus because we're given the power of hydrogen directly. Letter D can be found by hitting negative log of 1.0 E negative 7, and we get a value directly of 7.00. Again, always 2 decimal places with pH is required, and this is exactly neutral. Letter E gives us hydroxide ion. So when we hit the negative log of 2 times 10 to the negative 7th, we get a pOH. If the pOH is given as 6.698, 6.70, I will take 14 minus that answer to turn my to turn the pOH back into a pH. And this, my screen was saying 7.30, which is slightly basic. The only time it's exactly neutral is with two decimal places being 7.00. There is an A+ for Objective 4.